Welcome to this session of RRB JE for data structure, and I will take you through this various aspect of this data structure in this particular course. My name is Abhishek Sharma, and I will be taking this session for data structure RRB JE. Now, I'll begin with this small analysis of the paper, and this paper is from 2019 paper. 2019 paper, and here in this you can see that all the subjects almost having equal weightage here in this case, is almost equal weightage. Here in this case you can see that all the topics which is required for this RRB JE, system analysis design, Java programming, software engineering, PC software, computer fundamental, C language, computer organization, information system, data structure and C++, DBMS fundamental, system programming, operating system using Linux, web technology and programming, and system design, analysis and design, Java programming. Okay, so you can see that the weightage are here for this particular paper. You can see that 2019 paper is having more weightage here, as I can see here, computer organization. So rest of the part, system design is also having a very good percentage, 11%, and 10% two-digit weightage is for organization, web technology and programming, and system analysis and design. Rest of them are having a single weightage, single-digit weightage, percentage-wise. This is the analysis of the only technical section for this RRB JE computer science. Now, we are going to discuss, and the actual name is data structure using C++. But what I find very interesting here in this case is that when you read the name data structure using C++, you might be thinking that all the implementation should be in terms of C++. But analyzing the question, I did not get that. Maybe previous year questions. So during this analysis, I didn't get the C++ part. Yes, object-oriented programming, that particular term, and there are certain questions related with the properties of OOPs, encapsulation, constructor, destructor, that is basically friend function, friend class. So there are some question related with this object oriented programming, but not specifically C++ is merged with this data structure, that I did not find. So the meaning is that you have to good with the concept related with C++. And analyzing the paper, what I also observed that the standard of the question is very basic, very basic. So even if you go through the entire syllabus, and even you have a basic understanding of each topic, that will be enough for this RRB JE examination. Why I am saying it? Because the standard is that the question is not going into the details of every aspect. Second way, how to approach this any topic, not only for this data structure, any topic, try to be an study here as an application oriented study. Application oriented, that means you must be able to know that what are the application for that particular part. So application is important, that where exactly basically all these concepts are applied, and this is not applicable for data structure, this is applicable for all subjects. So basic, try to cover each and every part. That is the first thing that you have to keep in mind. Nothing should be left out, because the pattern of the examination is you have to score more and fundamental, and that meaning is that you don't need to go to the details of everything. Just go through this topic by topic. Basic fundamental understanding of each term should be clear to you, and that will be enough here in this case, and that I'll also show you. Data structure part, stack queue, pointer, linked list. So there is a stack, queue, and pointer is not a data structure. Pointer is basically a data type. Okay, pointer is a data type, and specifically in C language, C++ language, we have the pointer available. Searching and sorting algorithm. So now very small syllabus you can say, and that's why in the weightage also we can see that the number of question is only 6% of the question, and result in the syllabus is very small here in this. Okay, so this is the syllabus, and what I am going to do here, I have planned the session with the stack, queue, and pointers, linked list. Uh, these three are basically stack, queue, and linked list. All these three are a part of linear data structure. What is the because still the notification is not out, so I tried one extra topic here to cover, that is also tree also. So tree is basically these three are linear data structure. This stack, queue, and linked list. So this stack, queue, and linked list. These two topics are basically linear data structure. So there is a linear. These are linear data structure. And there is no non-linear. Linked list is also linear data structure. This is also linear. So I deliberately, though it is not right now, it is not in the syllabus, maybe notification out and then syllabus, maybe certain changes may be there. So keeping that thing in mind, I also think that the one non-linear data structure should also be, you must have understanding of it. So this entire data structure is incomplete without non-linear data structure, which is one of them I am covering in this case is tree data structure. So that way it is this. We'll start with the basic concept of the stack. You can see the books over here, and they are arranged one after another on the top of them. Okay, so each book is on the top of it, and they are arranged or stacked, you can say here in this cases. Now basic concept here in this case is stack is a container of data. Okay. So every data structure is not nothing but the collection of the data only. Every data structure. So data structure, how you define it? It's a collection of data. Data structure is about collection of data. Now collection of data, what to do with this collection of data, to how to organize, manage, how to organize the collection of data, how to manage the data, and possibly what operation that can be performed on the data, what operation. So every topic you have to learn what operation can be performed on the data. So it's about data organization and management, and each topic you have to learn considering this thing in mind. So it's a collection of data, but in this case it's a one-ended collection. So now what we do, linear collection. Okay, there is nothing non-linear. Non-linear later I'll explain you, but linear collection is that one data is arranged and then second data will come, then second, then third. So their interrelationship is linear in nature, like just arrange them in an let's say in a row or sequential manner. If you arrange them in a sequential manner, one after a sequential means one after another. That is a basically linear collection in this case. So now here what is stack is, in this case it's a one-ended data structure. The stack is a one-ended data structure. So one-ended data structure. One-ended data structure. That means what you are doing, that every instance when one end is blocked, then if one end is the block, then the operation that you can perform only on the single end. Single end is available only for the insertion also and deletion also. So for insertion also you are going to take the one end, and deletion also you are going to take the one end. So insertion is happening, you cannot insert from this side, only one side is there. So you will be inserting, and then deletion is happening, deletion also you are going to perform in this. And in this case, you can see that if this object is last inserted, last in first out, that is the principle that it is based on. And this is one of the question in the RRB JE, that what principle this stack data structure work on. So the principle here in this case is last in first out, which in abbreviation we use as a LIFO. So it's a last in linear data structure, and it's a last in first out data structure. Now, so it's a work on the principle of LIFO principle, last in first out principle. Okay. Now you can insert any time, but only the last or most recently object can be removed from the this collection. So insertion anytime you insert, but you want to retrieve it, then last. Then you will say that what is the meaning and why, what is the application, why we know, why we are blocking one end, and why we are basically not allowing the operation from any other places. The simple reason here in this case is many places, many things are there in our daily life, plus in computer many things are there which require that sort of facility, that like here in this case is that last value will be executed first. Application I am coming after this. We have two operations here, pushing and popping. Pushing and popping. So this is also basically one of the question in the RRB JE, that what is the push operation does. The push operation, and these are very specific term. We say insert and delete. Yes, but insert and delete doesn't give the sense that it is what type of data structure. So we have specific terms, push and pop. So pushing for insertion and popping is synonyms into the removing an item from the list. Now, one of the most common application here in this case is considered in a runtime stack. So now this is one thing that that one of the application, and directly coming to the application, because you have to understand that how the stack works, how the program works here. So what is a runtime stack? The runtime stack is a stack as a in computer for running a program. Now program running, definitely running a program happens through function call. Okay, happens through function call. Now with function call, there is possible that these functions calls are nested, a nested function call. What is the meaning of a nested function call? Is that there is a function main is calling, let's say, another function f1 and then f2. It's like that you are studying and somebody asks you, come and say that, okay, please do this task, please complete this task. Then what you will do that time? You, if you are reading something, then you probably note down the which page you are reading, you save that content and immediately go and try to complete that particular task. You are in the middle of that particular task, suppose you are arranging something, and then suddenly another person comes and says that, okay, leave this task, we don't need it right now, you complete this task. Now what happens? You have left two tasks here. Now the two tasks is still pending with you, studying and suppose arranging, and then you went outside. Then you come back, means you complete that task. Then what you will do? You arrange it and then finally go for study. Now that ordering, that particular ordering is maintained by basically by using the principle of stack only. So look at here, this is a nested, this is an example of nested function call or entire recursion. Recursion means a function calling itself, and the nested function call both are maintained by using the stack only. So in this case, main is calling f1 and f1 is calling f2. Something like main is doing this task, suddenly f1 comes and say, okay, execute me first, okay, then you execute the rest of the part of the main. Then what compiler does? Compiler saves this, okay, save your content of main, every information. Then it start doing f1. In f1 here in this case is you are doing some task and suddenly f2 comes and say, okay, now execute me first. The main is calling f1, f1 is calling f2. Then what you will do? Again you save the content of f1 and start executing f2. So that this process where you are executing a job, and suddenly in this cases switches to another function call and start executing that function. This is maintained in a runtime stack only. So there is a runtime stack. This is responsible for your switching of function call, and you can say the nested function call. Now this content, that main F1 and F2 that I am putting in the runtime stack, is basically not basically the function I am putting, basically a record structure, and that record structure is called as the activation record. This record structure is called as activation record. So we maintain each record for main, F1, F2, all our records are maintained. There are many substructures are there, but one of the parameter here in this case is called as a local variable. Okay, local variable. So you can see that in main function there are some local variables. Local variable. So local variable is what? Where scope is only main can see it. It's local. F1 is having can see and access it. F2 CD, only F2 can see and access it. Right? So these are local variable. Only function can see or and look into this. Okay. So that way this here in this case is local variable. Now local variable store where. So in this runtime stack, this is the first thing that you need to remember, and I think this is one of the question also, that where local variables are stored for a function. So that also stored in case of stack. So stack store them in a local variable is stored in the stack only. So here where is A and B? So that is in main activation record A and B. Where is B and C? So for B and C local variable for F1 it will be maintained, and where is C and D? So C and D is maintained in F2. Okay. So that way it is execute. Also I'll add another thing, that recursion. Recursion, what is recursion here? So recursion implementation, recursion is also implemented by using stack only. Recursion also recursion is also implemented through stack only. Okay, so that is basically one of the application, and as I told you that you have to learn the data structure as well as you have to also apply, you must know the application here. The two things I said, local variable where it is stored, then the stack only, how recursion is implemented, so using stack only. So this is the recursion, one of the very classical problem, the Fibonacci series, and in this case is we have when the recursion is implemented. So this is the whole implementation is done by using stack in this case. Now, pushing of an element will do what in this cases? So pushing of an element basically insert the element. So now here when we are inserting the element, one exception condition we need to check, exception condition, that is whether the container, the collection of data you are having, storage is full or not. Storage, the space must be there. So whenever we implement the operation, one of the condition we need to check, that is called that space is present for insertion. Space is present for insertion. So if there is a space, then only you are going to insert, otherwise this lead into one of the exception that is called as a overflow, and to be precise we can say here in this case stack overflow. If there is no space, somehow you are writing a program but there is no space, it leads to stack overflow. Similarly, empty stack means you cannot delete from the empty stack. Deletion or popping cannot happen. Popping of element, pop cannot be done from empty stack, and that's why this condition, and these are direct question, and this is the sort of situation you are going to face in RRB JEE. fundamental should be clear. No hardcore coding and all, no, not required. Only simple basic things. So that situation is called as a stack underflow. Okay, stack underflow. Okay. Now here one logical thing in this case is that we are doing push 10, push 20, pop, push 10, push 20, then 3 times pop, then 20 and this pop. The sequence, in which order the sequence will be, the element will be popped out. So you can now engage with this also, that you can solve question and respond to this. Let's see here that what is the answer for this, that push 10. So now we have a container which only top element will be accessed. The push is 10, sorry. So we are pushing 10 and then 20. So there is a 10, then you are pushing 20 and then you pop. A pop means here in this cases from this container this 20 will go out. The first element that has been popped from this container is 20. Pop. Then push 10, push 20. Again 10 and 20 has been pushed. Push 10 and 20. So it is popped, so 10 again and 20. Okay. Now, then again you say 3 times popping. Now popping will be, order will be about 20, 10, 10. A top element will be popped from this. So 20, 10, 10 it will be popped. So in this case it will be 20, 10 and 10 will be popped. And that will erase this entire content from this. That will erase this entire content from this. Now again push 20 and then pop. The push is 20, in this case is 20 and then again you pop it. So that will again take out the element 20 from this and that is this 20. Okay. So 20, 20, 10, 10, 20. In this case the answer here in this case is B. Now this is the, this particular question define that what type of the clarity you need for this RRB JE. Not very detailed, not very in depth, okay, just basic simple understanding of each topic and every topic. Now, so we can like here the process of inserting an element in the stack is called to create, push, evaluation and pop. Inserting, so inserting here in this case is called as the push operation here. This is another question that I am going to explain you after this, that what about the infix conversion of infix to postfix expression. So I'll come back to this particular question which is asked in RRBJ 2014 shift 1. After this understanding the expression. Now expression evaluation, arithmetic expression, expression evaluation. So recall that when we started understanding, after understanding operator plus minus division multiplication brackets, the first rule that was taught to you was the Bodmer's rule. Okay. So bracket order of and then this. So bracket order of, that means exponentation or maybe square root order of, then division, multiplication, addition, subtractions. So this is the Bodmer's rule is used for evaluation of an expression. So somehow that idea is taken in computers also for evaluation of the expression. And evaluation of the expression, these rules to be followed, that what will first, what is second. But it has been observed that if you want to evaluate an expression, the basic understanding and implementation of this Bodmer's rule is having some issues related with the time required for evaluation of it. So time required for evaluation, there is some issue related with this. Suppose I write the expression 2, 3 multiplied by 2 divided by 4 plus 6 and then multiplied by 3. Now, this is an expression, arithmetic expression only, this is an expression. Now within this expression you can see that what I need to do, I need to find out the within this Bodmer's rule which is first one. So division, then multiplication, then finally plus. So for that reason, what we need to do, what we require here in this case is repeated scanning is required. Repeated scanning is required. So for that reason, we need to repetitively scan it to find out that who is first, who is second. It has been observed that to just avoiding the repeated scanning, two notations. Remember the name Polish notation, that is the prefix part, and reverse Polish notation, that is the postfix form. These two things are being derived. Polish notation and reverse Polish notation, which we are known as prefixed and postfix, prefix and postfix expression. Now, prefix and postfix expression, once it has been evaluated, what is the properties of these expressions are that you don't need to search the precedence and associativity. Yes, you can evaluate them. Okay, evaluate them in a single scan. In single scan. So this evaluation of the postfix and the prefix expression can be done in a single scan. No need to maintain the ordering in this case. That is your no need to maintain your scanning required. Repeated scanning is required, and that is the reason that in a single scan it can evaluate this entire expression. But question is that how to evaluate, two questions, how to evaluate and how to convert it. Both questions are there, that how to evaluate and how to convert it. So this conversion, okay, this conversion of infix, what is our expression? Infix, that means A plus B. So A plus B to prefix part, this conversion to prefix, A plus B will become the prefix or Polish notation is done by plus AB, and postfix, this is AB plus, is done by the stack. So this conversion is also done by the stack and evaluation is also done by the stack. Now, so this is the core part for this stack, that how we implement is by using precedence and associativity rule. And precedence is that order in which, precedence meaning is order in which expression will be evaluated, order in which expression will be evaluated. So multiplication first, then addition, then division, this order, but that order is not applied here. I'll just, after this I'll show you the table, what is the order. So order in which expression will be evaluated, that is this. And associativity is if precedence is same. Okay, yes, we have some operator is having same precedence. If precedence is same, this is a bit of not exactly same as Bodmer's rule, because Bodmer's rule is not applied to the, like, adopted but not exact manner. So if the precedence is same, then order of evaluation, precedence is same, then order of evaluation is done by associativity rule. Right? So in this case is that precedence and associativity rules are basically order in which expression will be evaluated, and associativity come into the picture. If the same precedence is there, then what is the order here? This I have summarized, which is basically needed for this. Within that, you add the bracket part also, the bracket part. So bracket is having in this cases the highest precedence. You put the bracket, no rule required. And if you put the bracket in case of expression also, you can also change the precedence. You can also change the precedence, otherwise it will just follow the own precedence. Like here, if I say, if I write the expression in this manner, suppose I want to basically calculate the average of two value, and generally in the pen and paper I write the same value 6 plus 4 divided by 2. And you might be thinking, okay, yes, this is equal to be 10 because 6 and 4 is 10. But computer will not understand this. Computer will see that, okay, division. So this is expression from, you want 5, you want an average value as 5, but computer think in this way, 6 plus 2, because division is first and that is equal to 8. So precedence and associativity rules are basically in this cases matters. And writing an expression in a program, you have to be careful with this. Now there is a unary minus that is having highest precedence, then exponentation. Exponentation, sometime this up arrow and sometime a cap. Its precedence is right to left. That means if you have an expression 2, exponentation 3, exponentation suppose 2, suppose. So now here this expression can be evaluated in this way, or this expression can be evaluated 2 exponentation 3 and then exponentation 2. Both will get 3 to the power 2 is 9, 2 to the power 9 in this case is 512. And this one 2 to the power 3 is 8, 8 to the power 2 is equal to 64. So see that answers are different. But what is correct one? So in this case right to left. So now first you have to evaluate 3 to the power 2. And then you have to evaluate 2 to the power, the 3 is go with the operator on the right hand side. In system C programming also, multiplication, division and modulus all are same precedence and it will be evaluated left to right. Addition and subtraction is same precedence and evaluated left to right. Equal to is having lowest precedence. Equal to will be done at the end of it. Lastly, you are going to perform the equal to operation, okay, and that will happen at the end. So this is something about precedence and associativity. Now, so with this I can show you small example that how to proceed. A plus B minus C, and in this case for prefix part it will become first left to right, plus minus left to right. So first it will become plus AB minus C, and then this is work as a, now we will treat it as a one expression, single expression, and it will become minus plus A, B and C. Here for postfix AB plus minus C, treat it as a single one, and then AB plus C minus, that is your postfix expression here. So not taken the complicated example because I believe that again you don't need to solve the complicated expression, but still this table is helpful. Any complicated expression is given and your idea of the precedence and associativity is clear, you can still get the answer here. Now the next is how the expression is evaluated. Expression evaluation by using the stack. To consider this thing as a stack, and if it is the expression, postfix expression is given to you, then in that case you can go ahead and evaluate in this manner 2, 3 multiplication. Now here 2 is basic, 2 and 3 numbers are basically numbers or variable. So numbers or variable, number or variable is operand. They are operand. And plus minus, these are plus minus multiplication, these are operator. Okay, these are operator. So 2 comes, we push, 3 comes, we push, then comes multiplication. When multiplication comes, we pop 2 operand. and the expression that it will become, it become 2 multiplied by 3. Here 2 multiplied by 3 or 3 multiplied by 2, you will say same. 2 multiplied by 3 and 3 multiplied by 2 is same, but for division it will not be same. And for minus also it won't be same. So expression will become 6, but expression will be 2 and 3, means the top is top minus 1. Top is basically operand number 2 and top minus 1 is operand number 1. Then comes 6, then is 4, 2 and 2. Then again come multiplication. So again here order does not matter, but I'll write here as 4, and that is 2 into 2, and both are same. You won't feel anything. Division, then in this case is again 6, 4 divided by 4, which is equal to 1. See? Then comes plus, again order, what is the order here in this case is, so I'll write 6 plus 1, so that clarity will be there, who is first, who is second. Division, then plus we are done. 3, 5, 7, then 3 we push. 5, so 7, 3, 5 we push. Then comes plus. So in this case is we do 7 is there, operation will be 3 plus 5, which is equal to 8, and then finally minus. Now here it matters. Accidentally if you have done 8 minus 7, answer will become wrong. This is second number operand, this is first number operand. So answer is 7 minus 8, that is equal to minus 1. The answer for this question is minus 1. Please remember that the top of the stack is the second number of the operand, and the top minus 1 is basically here in this case, top minus 1 is first number of operand. That is how the expression is evaluated here. So that is the thing about the structure. I kept it brief, and even if that much understanding you are having for a topic which is stack, let me say that what I find from the previous analysis. Now suddenly after let's say 2019, suddenly this year RRB has been announced. So I believe that it will be around same level, it should be around the same level. Now Q. Now philosophy of Q is what? Philosophy of the Q is also taken from this practical Q that we maintain while we are purchasing tickets, or we are purchasing, we are doing the billing counter of any, let's say, shopping store. There is a billing counter, so you maintain a queue, and this lady is serving. Suppose she is preparing the bills. Now here understand that it's a queue, people are sitting, standing, and this is the front of the queue. This lady is in the front of the queue, and this lady in the last of the queue, and the technical term I am using, that is called as a rear. So definitely this is, you can consider as a resource, and this lady is using that resource. Maybe she is serving, but if there is another, let's say CPU is there, then in that case that's a resource, and everyone wants to be served, so that resource must be utilized by all the processes maybe. So she has been served and it is in the front of the queue. So now this woman is in the front of the queue, will be served first, and the moment she will be served, she will be gone from this, and technical term is this will be deleted. And another person comes in, where it will become, so it will not sit anywhere, or he or she will not jump the queue. Always go and stand at the end of the queue. That is basically insertion. So now here in stack we have only one top is the pointer, but in queue we have two pointers. One is a front pointer, another one is a rear pointer. So front and rear has been maintained for the queue. So Q is having two pointers are maintained, and in this case the two pointers are front pointer that delete the element from the front position. Pointer means index value. We need to maintain indexes. Okay, so which position element will be deleted? So in stack there was only one pointer, that is the top, who is on the top. And but here we have a two pointer, front and rear, that is elements are deleted. Now main operation in this case is called as NQ and DQ operation. NQ operation and DQ operation. So NQ operation inserts the element in the queue and DQ operation remove the element from the queue. Okay. So any application which is having a, let's say, a resource is there and there are plenty of them to utilize that particular resource, a queue is being maintained. Any simulation where, like here in operating system, you might have heard of ready queue and other types of the queues you might have learned of in operating system. So that is also the set of the processes waiting for CPU to be allocated. So CPU is a resource and these are the processes who want to utilize the resource. In that way, you think that every time there is a resource, we maintain the resource ordering by using a queue. So again a linear collection here in this cases. Now here we have two more important queues which is called as the priority queue. So now there is a priority queue, and nowadays also in airports also they maintain the priority queue. They give priority to some people for boarding in the plane. Okay, other peoples make the queues and they go one after another, first in first out, who is ever in the first, that will goes out first. Priority queue is that element can be deleted based on the priority. So element can be deleted based on the priority. And how it is implemented? To max heap and min heap, that is also a queue that you need to remember. And another queue, another special type of the queue, that is called as the D queue. And that means here in this case is a doubly ended queue. So what is doubly ended queue? So doubly ended queue is, this is having two ends. Insertion is rear and deletion from front. Insertion from the front, deletion from the rear, that also it supports in this cases. So that is the doubly ended queue. Operation performed on two ends. Operation performed on two ends. So basically this queue is a first in first out FIFO data structure, normal queue, and two more queues are here in this cases, that is priority queue and D queue. Remember those terms. Normal queue is also having two category. Normal queue is also having two category. One is called the linear queue, and another one is called the circular queue. There is a disadvantage associated with the linear queue, that even if the space is present at the beginning, once your rear pointer reaches to max minus 1, the queue here in this case is declared as full. So even a space is there, linear queue problem is that it declared as full. Is so that position present at the beginning and the rear pointers reaches at the end, so that time the queue is declared in this case is full. So to overcome this particular part, a circular queue is maintained, so that if you are reaching at the last position, it's a logic array is there only, but it's a logically we are connecting the last end to the front end. So whatever the disadvantage of the linear queue, that is overcome in the circular queue in this. Okay, so let's have look at some question over here before we come to this particular part related with stack and queues. Now, the process of removing element from the stack is called, so that in this case is called as the pop operation. These are very simple questions that is you can expect in the RRB JEE. User tries to remove an element from the empty stack, that is called here in this case is underflow. So that operation is underflow. Straightforward question, basic understanding. Pushing an element into the stack already having 5 elements and the stack size is 5. So now there is no space available in the stack, already full, and that leads to the situation which is called as a overflow situation. This is different. Now ordered stack entries in the stack is ordered. What is the meaning of this statement? Now this is different. This is not related with the property of the stack. Ordered. What is the meaning of ordered? Ordered collection. What is ordered collections? Ordered element. This term is used many times. Ordered collection. Now ordering is one of the property where what we can do, we can compare the key values. So I write 3 value 1, 4 and 8 suppose, and I say that can I compare this value by using this trichotomy property which is less than, greater than, less than and equal to. Can I compare them? Yes. So every time if the key values, key value means let's forget about the key value. This is the key value is a term that we use in database management, but also we use in data structure also for ordering purpose. So your binary search tree is a way of also ordering of the numbers, ordering of the key values, and that's why the key value term is used. So ordered means, like here ordering means this is one type of ordering. 148 is one type of ordering. 841 is one type of ordering, and 44881 is one type of ordering, though the element is I have taken repeated element, and 11235 is one type of the ordering. These are the different types of ordering is present. This particular one is called as the increasing order. Second one is called as a decreasing order. The next one is not called a decreasing order, okay, because means one element to another element, the element value must decrease, but here 4 to 4 is not decreasing. So this is not a decreasing order, it is called as, okay, 4, 8 and 1, okay, my ordering is flawed, okay, 4, 8, okay, 148, sorry, 148, sorry, 14488, that 14488 is not a, it's not an increasing order, previous, ignore one. This is not an increasing order, because 424, 828 values are not increasing, but yes, 124 is increasing. This is the ordering called as a non-decreasing order, non-decreasing order. This is also 1, 1, 2, 3, 5, increasing, no 1, 2 and not, so that is also example of non-decreasing order. And suppose I take 5, 5, 4, 4 and then 2 and 1, this is decreasing order? No, this is a non-increasing order, non-increasing order. So here coming back to this question, a collection of element is sortable. Ordered doesn't mean sortable. The entries may be compared with this less than equal to operation. Entries are stored in a linked list. Sequential, there is a sequential entry that 1 by 1. So is it the correct one in this case? The answer is no. The ordering is done with the operation which is less than. Entries may be compared with this less than or equal to operator. That is the meaning of basically an ordered collection in this cases. Now, which of the following is not an application? Parenthesis balancing, tracking local variable runtime, syntax analyzer, data transfer between two asynchronous process. Okay. Now, we have to evaluate. Now, sometimes situation may come which required more deeper understanding, but here this is the application I already told you. Tracking the local variable, this is one of the application. Now, syntax analyzer, so this is a cross, this is basically hybrid. So many different topics are being combined here. Compiler is also one of the topic. Now, syntax analyzer is having, there is a top down and bottom up category, and you need understanding of small bit of compiler design. It uses stack. Okay, it uses stack to check whether syntax is correct or not. Balance parenthesis, basically this is also we learn in case of theory of computation, some part of it. So suppose I'll just say this another thing to you, that suppose this is the parenthesis I have written, parenthesization, and it is balanced or not. That is also one of the application of the stack. What you have to do is, whenever there is an opening parenthesis, you push it. Whenever there is an opening parenthesis, you push it. Second one is also, first is pushed, then second is pushed. Third is also opening, you push it. So for opening parenthesis, you do the push operation, and the moment closing parenthesis will come, you pop it. So this is the first closing parenthesis, you pop this one. Second, you pop this one. Okay, so two elements are being popped, two parentheses are being popped. That means we are in this situation. Then again one opening and one closing. So again in this case you will get one opening and one closing, means this will be also popped. Then final closing one. The closing one means this will be also popped. So here you can see that after, at the end of it, what we have done, for every opening parenthesization, pushing has been done, and for every closing parenthesis, popping has been done, and at the end of it, if the stack is empty, then it is balanced. So now this is a balanced parenthesis. You can also check here, verify this, that this is one part balanced, this is one part, this is also balanced, and this is balancing this one. So this is balanced and this is also application. So last we are left with only this, the data transfer between two asynchronous process. That is not the application of the stack. So this particular portion is a hybrid, means taking different topics and then combining into this, and sometime it happens, okay, as an application. As I told you that whenever you learn a subject, also go through the application of it. Now this is also here in this case is that maximum number of parentheses appear on a stack at any time when the algorithm analyzes this. So you can also answer maximum number of parentheses that appear on the stack. How far the stack will grow. So opening, then closing will take out this one. Okay. You can also analyze this by yourself, that opening and closing, and see this. Opening is there, then opening and closing. So one length, two length basically, two opening, and then closing again length will reduce by one. Then again opening and opening. That means it will range, length will go to up to 3. So opening and opening. Look at here. This opening and closing I have taken out. So length was 2. Then because of this closing I have taken out. Then 2 opening. That means now length grows to up to 3. Then 2 closing. And 2 closing means this will be again taken out. So we are done up to this. Then again 2 opening. Again 2 opening. And then 3 closing, and that means 1, 2, 3 will taken out. So now when I analyze this, maybe one by one I have not done, but in this case remember that this is opening and then opening and closing. So opening will put the value and closing will erase it. then 2 opening. So there is a 2 opening, length will become 3. Stack size required is 3. And then 2 closing. The 2 closing will again in this case will erase this one and this one. Closing. Then again 2 more opening. And that means again stack size will reach to 1 and 2. And then finally 3 closing will take out all the 3. So with that I figured out that in this case is that the height that is maximum growing in this case is 3. Okay. So height is going here in this case is maximum is 3. Answer for this question is 3. Okay. So now this is a very small session that I have taken for this data structure, and I could cover only in this cases 2 topics. Maybe for other topics we can also, I wish I could have give you more insight about those topics so that within this you can summarize and understand that what is the standard of this and where you have to focus. Do I need to go to details of everything? So really not required. There may be one odd questions may be present, but that among this 100 question you can take that risk that not going on deep and covering maximum number of question. Okay. So I wish that the things that is explained to you is fruitful to you and enjoy the session. That's all from my end. All the best for all of you. As soon as the notification is out, you will be informed. Please keep following the YouTube channel of this ACE Engineering Academy for the latest update, and more session to follow. Still we are conducting the session and more session will be followed after this. That's all. Thank you very much.